In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a product. It says evaluate the following limit using L'Hopital's rule. Limit as x approaches infinity of 5x times sine of 1 over 7x. Now you'll see if I plug in infinity into this 5x piece, we will get infinity. So this is going to equal infinity. Times, when I plug in infinity in here, I get 1 divided by infinity. 1 over infinity we know is 0. So what is sine of 0? Well, that is, sine of 0 is 0. So I get infinity times 0, which is indeterminate. So I'm going to use L'Hopital's rule now. And to use L'Hopital's rule, I need to create a fraction between this 5x and this sine. So I know that 5x is really 1 over 5x. If we took the reciprocal and multiplied that, we'd end up with 5x. So this is a little trick, algebra trick, that we're going to use to be able to apply L'Hopital's rule, because we need fractions to apply L'Hopital's rule. So we're going to say the limit as x approaches infinity, and we're going to rewrite this as sine of 1 over 7x in the numerator, and then the denominator will have 1 over 5x. And remember, if we flip and multiply this, we'd end up with the same function, right? So this is the same as the original. Now we're going to apply L'Hopital's rule by saying the limit as x approaches infinity. And we're going to do the derivative of the numerator, so sine of 1 over 7x, and the derivative of the denominator, which is 1 over 5x. When I do the derivative of the numerator, I'm going to get a chain rule here. So I've got limit as x approaches infinity. Derivative of sine is cosine, 1 over 7x, times the derivative of the inside, which is 1 over 7x, over derivative of 1 over 5x. So I'm going to write this 1/5, and I'll just do the derivative right here. I'm going to do the derivative. This would be really of 1/5 x to the negative 1. Right? Bring the x to the numerator there. So when I do this derivative, negative 1 comes to the front, I get negative 1/5 x to the negative 2. So I can now rewrite this as, in the numerator, or the denominator, negative 1 over 5x squared. When I do the derivative of this 1 over 7x piece, derivative of 1 over 7x, it's going to have the same properties that we just did with the 1 over 5x, except for we bring this to the top, that'd be x to the negative 1. We bring the negative to the front. So we end up with, let's do the derivative again. We'll write it here. The derivative of 1/7 x to the negative 1 is going to be negative 1/7 x to the negative 2. So then I can rewrite all of this. This would be the limit as x approaches infinity. Let's rewrite this piece out front here, and we would have negative 1 over 7x squared being multiplied times cosine of 1 over 7x, and that's all over negative 1 over 5x squared. Okay, now what we can do here is we are going to be able to do some simplification. So we can actually now take this piece, take the reciprocal, and multiply it to the top. So I end up with negative 1 over 7x squared cosine of 1 over 7x, and it's going to be multiplied times this reciprocal of this, which would be negative 5x squared over 1. That's going to give us, I should have wrote limit here, limit. So this would have been limit as x approaches infinity When I multiply negative 5x squared times this piece, the negatives are going to cancel and I get 5x squared over 7x squared cosine of 1 over 7x. The x squareds are going to cancel, and I end up with limit as x approaches infinity of 5 over 7 cosine 1 over 7x. If I apply the limit now, so plug in infinity here, I will get 1 over infinity, so I get 5 over 7 cosine of 1 over infinity. Remember, 1 over infinity is 0. So I'm going to end up with limit as x approaches infinity. Actually, sorry, I don't want to write that there. So this is going to equal cosine of 0 would be 1, so I end up with 5/7. So I can now write this. This is my f of x function up here. So I can say the limit as x approaches infinity for f of x was equal to 5/7. And that was an application of L'Hopital's rule.